And it's joules. What does that turn out to be? So that's going to be about 1, right? Is that right? No, about 2. And this is going to be, so we need 2 times 4. So it's about 0.0818. Is that about right?
Yeah.
Yeah. Okay. So my initial total energy, what is it?
0.018.
Yeah, 0 plus 0.018, so 0.018. Now here's the deal. Kinetic energy final, it's not 0, right? If your final speed is 0.4 meters per second, now you need 1/2 times 0.2 times 0.4 squared. It'll be that many joules. So half of 0.2 is 0.1, and that's 0.16. So is it 0.016? Okay, that's my final kinetic energy. Now, your numbers aren't going to be exactly this, okay? This is just, I'm ballparking it for you. So this is 1/2. Oh, wait, that's the sum. M VF squared MGHF. Well, what's HF? That's what we're calling 0.
0.
Because the top of the air tract, the one-footed end of the air tract is going to be 0.9 centimeters, 0.009 meters above the two-footed end. So it's 0. And what's the total energy final? Well, it's the sum of these two, KE final plus PE final, and it's 0.016. Okay, so here's what you're going to do for percent difference. I want a comparison between the final total energy and the initial total energy. So you're going to do a percent difference calculation that looks like this. Total energy initial minus total energy final, and it should be the absolute value of those, divided by total energy initial plus total energy final divided by 2. Okay, that's the average of them. Now, I'm going to tell you right now, if you end up with a total energy final that's bigger than your total energy initial, you probably did not level the air track. I mean, that would be my first guess. Because we're expecting them to be the same, right? And we are not expecting, if we've given this initial potential energy, we're not expecting it to gain energy from the air so that it's got more total energy at the end. This should be at most the same, and if there's not much friction, they ought to be really close to the same. So is everybody with me? You want the leading edge of the glider at that 50 mark. Or maybe do you want the post? Let me think about that.
Yeah, it's a center.
A center, okay, thank you. My bad, you want the center at the 50 mark. Yeah, that makes more sense because then that gives you the speed roughly halfway through here. Okay, so that's experiment 1. Now let's see. Experiment 2, exactly like experiment 1, except for experiment 4, this is going to be 4 times that. So that's 0.036 meters. This is experiment 2. Okay, everybody with me? So the only difference for experiment 2 is we're putting this on 4 blocks instead of 1. And now, what would you guess is going to happen to the speed down here?
Faster.
It's going to be greater, right? Should be going faster down here. But the energy should still be conserved. So are you with me so far? Okay, now, the third experiment. The third experiment, that's when you need this other photo gate. And really what you need is, this needs to be the one that's plugged into gate 1. So if you're going to leave, I would leave that one at 2. Leave that one down there. And I would just plug that in to gate 2. And then make sure this one's into slot 1. And now what you're going to do is, do I tell you to start at 20 centimeters or 30 in front?
180.
At the 180. So from my point of view, it will be at the 20, but on this side, it'll say 180. Okay, so just make sure you're wrapping your brain around that. So you're gonna open 2-gate timing, I think. Is that what it says? Now you go to Logger Pro and you open another timing program that controls 2 gates. Does it say that 2-gate timing? I hope it says that.
Yeah.
Okay, good. So, you open 2-gate timing. You've got this 30 centimeters ahead of the 1-foot end. And now you start the timer, you let go of it, and now it's going to have a speed when it reaches that one place. Oops. So that would need to be up higher. It'll have a speed there, and then, of course, it's got a speed down there as well, a bigger speed. We're still calling this the zero of potential energy. So now, I hope you were able to jot this stuff down, or you had some sense of it, because what I want, maybe I'll just put experiment 3 down here. And but percent difference is in the way, so. Okay, so for experiment 2, or 3, now VI is not going to be 0. And I'm going to say VI might have some value like maybe 0.5. Around there. And HI is 0.036. And V final is going to be something more like, I don't know, around 1. A little less than 1 probably. Maybe 0.95. I mean, you're going to have slightly different values. So, and actually I think you're reading these to the nearest 1,000. H final is still 0. So now your kinetic energy is not 0. It's going to be 1/2 times 0.2 times 0.5 or whatever it is squared. And your potential energy initial is going to be 0.2 times 9.8 times 0.036. And your total energy is, of course, the sum still. And kinetic energy final, so that's going to be 1/2 times 0.2 times 0.95 squared. And potential energy final is still 0. That's the only thing that is 0 in the third experiment. So then you do everything else the same. Okay? Got it? Okay, go do physics.